Ladies and gentlemen, please take your seats. The show is about to begin.
All right, what's up, everybody? Welcome back to another episode of On the Wire, where we dig deep into what we're building here at Wire Network. We talk about the crypto industry, bring in special guests, and today we've got Kyle, Dolan, and Ken DiCross, CTO and CEO of Wire Networks, and we're going to talk all about how the blockchain works, our strategy, the philosophy here. We're going to dig deep into some technical stuff. We're going to go all over the place here, really, as we kind of discuss the nuts and bolts of the network itself, the performance benefits, what we're trying to accomplish with the trustless hardware, kind of how it fits into the blockchain itself. So anyway, without further ado, let's bring in Kyle and Ken. What's up, folks? How you guys doing today?
Hey.
Hey, everybody.
Yeah. By the way, my name is Raymmar. I don't think I introduced myself. I am the CMO. And we've got some slides here for you. So we're going to bring those slides in. Let's see who we got in the audience. We got John Day. Hello, hello. Ooh, let's bring those up on screen. Hello, what's up? Swamp Daddy in the house. Oh, that's you, Kyle. Hey, Crypto 6 Foot is here. Crypto Orange is here. What's up, One Jojo? You can feel the spark of this project like the first sign that a volcano is about to erupt. Okay, let's go. We're excited about that. Feel free to let us know where you're watching from in the stream. If you're in the chat, we appreciate that. Give the video a like, and we're going to jump right in. Ken, why did you want to have this conversation? Talk to me a little bit, set this up as we go through here and kind of just set the stage.
Yeah, well, personally, I think I said it before. We have the interoperability, we have all these protocols, but every time Kyle gets into the hardware and what the current issues are in the space, what our solutions are, like it gets me more jacked up than anything else that we discuss. So I wanted to have a dedicated stream about this. Also, when I was at Satoshi Roundtable, I posed a topic there that was hardware attack vectors, exploits, things of that nature. And mind you, when you pose a topic, anybody can come to it. And there's also about 6 or 7 other topics that are being posed by other people. So people can go wherever they want. And the hardware topic that I posed had one of the most populated topics. Like, you know, we're talking about over 30 people at this talk, and everyone was very involved. We had a great conversation. It wasn't just me pontificating. It was everyone was coming in, giving their aspects, you know, of what they know, what they don't know. And overall, you know, from a blockchain community perspective, that's what it's going to take for us to solve this problem. It's going to be a group effort, and but we need to get there. And during this conversation, you're going to see exactly why this is a high priority problem that we have to tackle.
Nice. Kyle, any thoughts before we get started here? We're going to run through an outline of what the stream's going to be, and then we'll dive right into the meat of it.
Yeah, no, this is a really fun topic for me. I'm excited to go in.
Nice. Okay, so let's take a look. We're going to talk as an outline here, issues with the current blockchain infrastructure. We've talked about this a little bit, but we want to kind of rehash this so that we have it all kind of encapsulated in a single stream here. We're not going to dive too deep into those because you can go back to our episode on interoperability and get a real kind of handle on some of that. But we want to, again, just bring everyone up to speed in case you're watching and it's new to you. We're going to go over the differences between decentralized and trustless. Those two things, those two words, everyone's talking about decentralized, but decentralized doesn't always mean trustless. And so we're going to talk about the core differences there and why that matters. We're also going to talk about our approach to trustless hardware and why we think that's kind of the unique piece here. Performance benefits that come along with marrying our blockchain with the trustless hardware. We'll talk about the Wire blockchain nodes and kind of a little bit of how that governance and structure works. We'll share some final takeaways. And then next week, we just got a little sneak peek, future of crypto gaming. We're going to have some special guests to talk about how this technology applies to real world applications. why these things are required for mass adoption and for these things to be able to hit the mainstream. And so what you're going to see is we'll start slowly stacking different things on top of this thesis that we're going to lay today that will help you understand as we go and as we grow the bigger picture of what we're trying to build here. So current blockchain infrastructure issues is where we're going to start. We're going to run through an overview of the Bitcoin, Ethereum, and altcoin infrastructure. We're going to talk a little bit about how ours is different than that. So Kyle, Ken, I'm going to kick it off to you, and yeah, let's do it.
Yeah. So I'll start with Bitcoin, and that's going to include like Litecoin, even Ethereum style networks that are still proof of work. They're going to be in a category where you've got lots of very specific machines doing a really specific operation well. And so you have ASIC miners, you've got CPU mining, GPU mining. Essentially, that is the underpinning of Bitcoin and other networks like that. And the idea is that difficulty increases based on the amount of compute or hash rate, being submitted to the network. And it's really decentralized. There's lots of hardware everywhere. Everybody knows you can plug a little USB ASIC in and mine Bitcoin or something like that. You're not running anything fancy beyond, just protecting consensus of the network and ensuring that, things can be broadcasted to it. Big issues in Bitcoin, even early days. We saw updates to popular mining clients censor, specific accounts. The whole topic is called miner extracted value. So it's where pools or, big components of the hash rate find ways to do other things for other reasons. Beyond, simply trying to earn the transaction reward or coin reward. Then you've got the more modern blockchains that are going to be like your proof of stake blockchains, everything around that. Lots of different form factors there. They're essentially, they've all mostly taken the approach to make it as simple as possible to run a node. And they want as many nodes as possible. You have different styles of reward where like Ethereum validation nodes and elected, authoritative block producers. It all essentially boils down to this, though. Their open source software is going to get deployed to like an Amazon EC2 instance or some type of virtual private server that in almost all cases will boil down to an Intel, CPU at some point. And a bunch of trust issues there. Even above that, I think I've seen statistics around the Ethereum mainnet's compute is like almost a fourth of it comes from AWS alone, and that's kind of like the layout of the land right now.
Yeah, I actually wrote a Medium article about that. About 25% of all Ethereum workflows are on AWS. So we're jumping a little ahead here, but I think it's good to kind of set the tone. Kyle talked about two key aspects. Is number one, we're talking about the hardware itself. That is at the lowest level, what the problem is that we're identifying and trying to solve. But Kyle's already talked about there's actually a layer above it that's also centralized, and that's AWS. So when we're talking about how to create, coming up here in this conversation, a trustless environment, you have two issues. You have one, the hardware itself, but then when you are running your applications on AWS, that's another attack vector potentially where Amazon itself could just flip the switch off. So it's not even about exploiting the hardware. It's about a centralized company that might not like what you're doing, even if it's not illegal. They have pretty much full authority to just shut you down. And so those are two things that we have to get away from if we're going to have, our way of a future internet.
Yeah, I mean, Amazon could be in a position where they're compelled to, suspend service for specific validator nodes even. That's just the nature of it being centralized in one, on one platform.
Come back to like, this is ethereal shit. Maybe AWS will do it sometime. Let's come back to what's happening right now, because Ethereum has censorship in its current, like there's problems with it right now, right? So like there are problems on the Ethereum blockchain where, what was the stat you gave me, Kyle? Like certain percentage of transactions just have some level of censorship. And what that means is certain people are not being able to transact through the chain, right? And
so we can
these
measure
are real
like
problems right now, right?
Yeah, we can measure transactions that are broadcasted, and we can see how many blocks are affected by that where they're not included in the block. Because you've got large, even above like the data center layer. If you just look at like pools, they're organizations that can be compelled, or autonomously they can decide if certain types of transactions shouldn't be included in the block without breaking the continuity of the rest of the blockchain. And I think that issue is becoming more well known. But what a lot of people aren't aware of is just how many layers of trust exist. That when you're depending, when it's your money, it's your assets, you're expecting the blockchain to be trustless and immutable, and it's really not the case. That's good right there. So I mean, they're talking about these issues. Tornado Cash is a big one. That was basically censored by all the biggest organizations that control, the lion's share of validation on Ethereum.
And there's real world examples of censorship and things that are going on that will translate into what we're talking about on the hardware and even on the software layer. I mean, you look at like GoFundMe, for example. GoFundMe is a company, and they are basically allowing and not allowing certain organizations or certain topics to be funded or not funded through their application. They're essentially being kingmakers. They're deciding who gets in and who doesn't. You have, this was the big thing with Twitter, is Twitter was, censoring and removing people from their application for allowing them to have a voice and get to speak. Now that's political. There's all this stuff into it. Peel away the political. Just talk about purely like what's happening. You have companies that are censoring people in organizations. Now this is where I'm getting into the Amazon, the AWS level of this. Is AWS is essentially that same kind of central organization where if they set their sights on applications or blockchain applications, we can have some sort of a similar scenario, whether it's just or not, they have the power to do something like that, and we need to get away from it.
Yeah.
And we have examples of them doing it in the past. They've off-ramped platforms from their infrastructure, and that's documented and well known dozens of times, hundreds of times.
If you're watching at home, what we're looking at here is this MEV watch. Some MEV boost relays are regulated under OFAC and will censor certain transactions. This is what we're talking about here. This is kind of showing the level of non-compliant versus compliant transactions. This is going back all time, so it's showing almost 20% of all transactions. Let's say if we go back to the last 30 days, almost 35% there. And then it's got like a leaderboard of where these transactions are coming from and what percentage of their transactions have some level of censorship or not. And then you can kind of see on a scale here how that's kind of playing out. So we're all familiar with censorship from like a technology or a speaking standpoint or an idea standpoint. We've heard it. We've even seen the people like losing their entire careers for speaking out. And this is just like from the social sphere. Just because you get can't be on Twitter or can't be on Facebook or Instagram, you could still go spend your money at the store, right? You could still go to shop. You can still go to the mall. You can still go out to eat. But when we start talking about censorship on these transactions, and let's say we're down the road 10 years and this is your credit card and you're trying to pay and now you're censored, like what happens? Like, are you not able to transact? Are you not able to exist anymore? You know, like this is why these things become really important to the conversation we're trying to have here about how this plays out over time, because, you know, censorship's one thing to be said about social media, but when you're talking about cutting people's ties off to their wallets, you got a whole different ball of wax, you know?
Yeah. And I mean, it's a big issue. I think most of the new and upcoming protocols they're trying to come up with unique ways to deal with it. Our approach is to create a trustless compute platform. And essentially, if you have no ability to operate a node in a altered state, like it can only do what it is going to do, what you would expect the code to do if you looked at the repository, just like kind of how this has all been presented to us for how Ethereum should work, how Solana should work. It's disingenuous because, as you just showed, you know, it's not a big deal for them to censor types of transactions scope to like a certain smart contract or even specific accounts.
Let's try to bring this back in though. Let's set the stage just a real quick little bit on decentralized versus trustless, so then we can get into like the specifics hardware problem we're solving. So a lot of people in the space use the word decentralized for like everything they talk about, but in that context, like a lot of the web is decentralized because it happens in lots of different places. But that doesn't mean it's trustless. Things can be decentralized, but not trustless. So, Kyle, do you want to give us a quick little rundown here, Ken? Who wants to take the first swing at just this setting the stage? And then the reason we're setting the stage is because next we're going to talk about from here on out is basically wire hardware, how it fits into the blockchain, and we'll just kind of dive deep into the nuts and bolts there. But who wants to start out here?
I'll jump in real quick to just set the stage, and then I'll kick it over to Kyle. So this is something that I really want to separate the wheat from the chaff here. Is we talk about as an industry, even myself, we say decentralized very often with, you know, in our sentence structure when we're talking about blockchain and what we're trying to do. But what is decentralized? Decentralized just means that it's spread out, that everyone has a little piece, and collectively, you know, there's not one single point of failure. If one little node goes down, there's another 1,000, 10,000 around the world, keeps the chain up, keeps everything going. That's decentralized. What we need to get to is trustless. Now, trustless doesn't always mean spread out and decentralized. It can mean you know, dense or condensed. But decentralized doesn't always mean trustless. So we need to get to that kind of a conversation where we're talking, because, you know, you can have a decentralized a DEX, a decentralized exchange that's sitting on AWS. Is it really decentralized? Yeah, it has nodes everywhere. Is it trustless? No. Amazon can flip that switch and shut them off. So we need to get to a trustless environment where, you know, we're not allowing central figures to dictate whether we survive or not.
Yeah, and lots of people are familiar with the concept of trustless if you're familiar with crypto, but if you're not, this idea of trustless essentially just means that it doesn't require you to trust anybody to know that what is said as being done is actually being done. Right. So like a lot of times in human relationships, you trust people and that you trust them to not be lying to you or to be doing what they said they're going to do or to follow through with a promise or whatever it is. Right. And that's how we build reputation as individuals. But that's also how we corrupt systems, because you might build some trust and then you accrue that trust, Sam Bankman-Fried, and then you run away with the money and you don't actually deliver on the goods. And so the idea of trustless versus trusting something is you don't have to trust it. The trust is not required. The system validates it. This is the whole concept behind a blockchain, and why Bitcoin is what it is, and why this whole industry has kind of evolved to this point. But just wanted to make sure that distinction was clear of what this word trustless actually means. It's that there is no checks and balances. The system's open, being vetted all the time. Kyle.
Yeah, no, well stated. I mean, a huge issue in, kind of like the height of the last cycle was performance, efficiency, and the easiest ways to quickly get there is to ditch, the trying to be a fully trustless platform. Even today, I would look at almost every protocol. Most of the way that you actually get the blockchain data to your device, your computer, your phone, is going to come like almost. I would gamble way more on a percentile from like an Amazon. That I'm talking about RPC data, Infura. There's these big businesses that have been built that are definitely centralized, and also have been pointed out to be doing nefarious things like censoring entire countries by IP address to prevent them from being able to interact with the network itself. Even though the network doesn't have anything to do with that, even your ability to reach it is a big issue. And when you get to if you're going to build a trustless internet, that means that you really need to remove any kind of potential obstacle or attack vector for centralized organizations to corrupt the system or find ways to censor effectively what they want.
Yeah, so there's three kind of organizations that are going to try to attack a system. You have black hat hackers who are going to try and exploit things for personal gain, or just to, just ego that they've disrupted something to carry that trophy. You have potential people inside of these organizations, like maybe inside of Intel, AMD, where if they have God tier access to what's happening inside of these chips and on these boards, well, then they potentially have we're trusting them right now to not do that, but that's what we're trying to get away from, because they do have the opportunity to potentially dive in there and pick out some information. Or you have government agencies who, across the world, we're not just talking about the United States. You have governments across the world who might want to attack an application or a blockchain, or anything like that, and it could be doing it, or they could just put pressure on the centralized companies to do it for them. So there's three verticals that we need to watch out for and set up guards and barriers to allow us to have that decentralized and trustless environment.
So let's go from here into then the our approach to the trustless hardware, why it's important to deliver that secure and transparent compute. Kyle, let's start this with, you were telling me I don't remember who it was. There was like a story about Dell or something like that with they had some links to buy computers that had been neutered with that IME on their website.
Oh, yeah.
Popped up or something like that.
So let me just say what the Intel Management Engine is. I know we've said it many times on the stream, but essentially you've got this software that nobody can validate, and Intel doesn't release it or allow it to be audited, by other companies, and especially not, the public. That is it has the highest level of trust, on a computer. What that means is it basically has the ability to affect any other system on the computer, no matter how it's built, what your software is going to do to try to prevent itself from being modified. That's going to be able to happen at that layer. From there, you're basically looking at an infinite, field of like take your pick of what you want to do. You could change like the ability for data to come in over the network. You can just prevent certain aspects of the software from running. You could do whatever you want. You could run entirely custom software and you could do all of this without any kind of audit log or firewall that's in place around the main part of the computer from even being aware of it. You can just go right around it. It's got its own ability to do transactions over internet protocol.
And let's look at this article I just pulled up here. This is from middle of last year. Leaked internal chats from Conti ransomware gang suspects the group has been researching and developing code to compromise the Intel management engine, the out-of-band management functionality built into Intel chipsets. So there's got to be lots. I mean, this has been a problem for a while. And then it goes on to explain kind of what this is. This problem has been present for a while. It's been known about for a while. But I have to imagine that more and more people maliciously are going to start to figure out how to do this, especially as more and more people move money and commerce moves into these digital systems that we're building all around us, which again goes back to the need for what we're doing and why.
It's a pretty high value target. I mean, if you find a way to exploit the Intel management engine, you found a way to exploit almost all servers in the world, all personal computers, or a lot of them now. And then, yeah, like full backdoor into those machines and everything they do from.
Well, and we don't know that it hasn't been compromised because it's not the kind of thing that anybody would tell you about.
Yeah, and to your question, so Dell accidentally showed on their website laptops that have a neutralized management engine that aren't available to the general public, that are specifically available to like government agencies, militaries. Oh yeah, there you go. So essentially, like if the Intel management engine was a good thing for your computer, the military or government agencies would just enter into a deal with Intel where they can like audit the code base, and they probably did do that. But the fact that they specifically buy computers without it that aren't publicly available, why would they do that? I mean,
yeah, it says right here, like the laptops are available only by custom order and only to military, government, and intelligence agencies. They're specifically designed for covert operations, such as providing a very robust case and stealth, blah, blah, blah. So yeah, these things popped up on their website. Basically, that's what it's saying here. In December, Dell began showing certain laptops on its website that offered system management option, Intel versus Pro IME inoperable, custom order for an additional fee. Dell had not announced publicly or explained the methods used. In response to the press request, Dell stated those systems had been offered for quite a while, but not for the general public, and had found their way to their website only inadvertently.
Yeah, so it's pretty funny.
Raymmar actually
essentially like.
Go ahead.
The fact that these big organizations that where security is there's no price too great. Why are they sourcing computers that don't have the Intel management engine in place? Or on the AMD side, they have the same thing with their platform security processor. So we need to get rid of that. And then there's a lot of companies that are trying to create, personal computers for the individual that have that software neutralized. But there's not a lot of, server platforms available. And there are varying degrees, to how these engines are neutralized, because they literally make the chips so that they do not run if that management engine has been modified in any way. So the problem is alternative currently to run a server other than AMD and Intel. There's new open source architectures on the horizon that are still a long ways away, like RISC-V. And then there's old, technologies that are available, but they're too slow for, the types of needs that these new applications have. Like you've got like the IBM Power 9 line of processors, and they just don't compete, with what AMD and Intel have been able to do.
Yeah. Kyle, I want to get into a little bit about what exactly we're doing that's different. I know that we've had
I think your audio cut, Ken.
Check. 1, 2.
Can you hear me?
I can hear you. Kyle, are you not hearing us?
I hear you. I don't hear Ken.
Interesting. You might need.
But maybe he's going out to the stream.
You may need to refresh. Yeah, we can. Yeah, he is. And we are.
Well, Raymmar,
Cool.
well, I'm going to refresh.
Yeah. So
have Kyle
you got the
talk
Intel
about
Management
hardware
Engine. You got to deal with that. There's some other things like it that I won't go too into, but there's various chips on these motherboards that have important roles, and you're really just you got to deal with it all. We even go as far as to like deal with eliminating firmware required for system memory, for storage on the servers. We're trying to push the needle forward on all fronts to have a fully open source stack, no black box software, while still being able to use these modern processors and giving us the horsepower we need to, really power the network and scale it over time.
So let's talk a little bit about, just a little bit about that, right? Like and I don't know how deep we want to get here, like on that, are we going to dive into the boot state, like where we are in the process of actually, because we're designing chips and doing things and like not chips, but kind of the backbone of this stuff, right? Like we're going all the way down to the core boot, right? Like the OS, not the OS, but the firmware.
The vision is, to have a core backbone platform that anyone can independently audit and verify that it's doing what it's supposed to be doing the same way we would expect blockchain's open source code to be validated, or a smart contract to be validated and verified that, it doesn't contain exploits and it's actually doing what it's supposed to be doing. We need that to be possible at the hardware layer, and that's what we're doing. So it's a pretty large challenge, but we've made like a lot of leaps and strides forward, and we have a really solid machine and stack running. So I don't think I haven't seen any other, even if you just look at like Web 2 server platforms trying to be fully open source, that's not something you can just go buy right now, unless you're a 3-letter government agency and you call Dell.
Do you think that, just playing devil's advocate here, is that something that's, other than like an operation like this, is it viable? That's why that's why the investment, you need the investment to build new infrastructure, to build these new things. But are you fighting it seems like, are you fighting the government and you're fighting all these other entities? It's like you're fighting the whole monster to try to bring this to life here. So talk a little bit about, kind of the importance of that. And then let's go into like why there's such a benefit to doing this stuff, right? Like that's the real thing, is kind of creating the opportunity here for some of these innovations that people talk about to take place, and really for the stability of, societies, right? Like for free markets and open markets, and, for people to be able to know and trust the money they use and the way they interact.
Yeah, so we're going to get to a point where if you want, you could, one of the key pieces of our stack is our hardware security module that is fully open source. And that's key because that is the hardware enclave for authoritative keys. In order to make sure that you can't be compelled to manipulate the machine state, by a third party or a big organization or whatever, you need to not have custody of the machine, but you still need to have the power to authorize the machine and authorize many machines, because we want our appliances to be, spread out all over the place, and make that more and more redundant and decentralized over time. So in order to do that, you need a really good hardware security module, and there's never a requirement for you to protect those keys and no one can ever see them. You get the public key out of there, and then you interact with our governance contracts on our chain, on other chains, because we also want that to be decentralized. That's a really important layer. And you authorize those. And then what you're able to do is, with software or even through your independent routes, audit and validate the machine state all the time, anytime, and deauthorize the keys as your either on or off switch. So there's no in between. There's no edge for you to, when we were looking at the MEV issues, they don't have to turn the switch off to mess with transactions and censor some of it. In our case, our approach is, if you want to censor, you have to turn it off. So you'll know if the Wire network is producing blocks, that none of that is happening. So,
Kyle, are you able to hear me?
Yeah.
Okay, great. So that was exactly what I wanted to about that. That was perfect, because I think that's a real differentiator for what we're trying to do. Raymmar, what you said right before that, I want to touch upon, which is we're not doing this from an anarchist point of view, right? When we're talking about, about like skirting the government, or, however you want to look at it, we're looking at it from, this is blockchain. These are your assets. These are your identity. And we have to shield, if we're going to play in this sandbox of a future world of digital assets, we have to secure these things as much as we can for our users, right? We can't just have a black hat hacker just be able to throw a fishing line in the water and just pull up as much money as it can't be an ATM for either companies and or black hats to just come in and impose their will. So it's not like we're not going after it from like a government perspective. We have to secure and have everyone feel secure to participate. Like, I'm old enough, and I know you guys are too, that I remember the world where you would not put your credit card online to make a purchase. Way before Amazon, way before, even eBay or whatever, before PayPal came, you did not put your credit card online because you knew there was a very good chance that there was somebody able to see that, your credit card information and then go and take it away. That's where we're at now with blockchain. And we have to get to that secure, standpoint in blockchain, but that's just not on the software level. It has to be hardware too, or we're never going to reach that goal.
Yeah. So let's talk a little bit about, I think we can all agree on that, right, Kyle? Any other thoughts there? I'm thinking we could go into talking a little bit about the performance benefits. We can talk a little bit about the nodes.
It's a really exciting part. Yeah.
Yeah. Like, now we've got a good kind of fundamental underlying understanding of why, the hardware is important, why the things are kind of a little different here. And so, yeah, dive into, what the fruit of that labor is intended to be.
Yeah. So what we figured out is when you go the route of trying to create a trustless compute platform, there's some unique opportunities. When I was talking about the hardware security module, because of the separation, between a person that owns a node and they're, participating in the proof of stake consensus workflow, because it's separated from custody of the physical machine and the keys and the software running on there, what we can do is we can have every authority, like authoritative node owner, have authority in all the machines. So it'd be like if every Ethereum validator had unique sets of keys for everybody who's staking on each machine. And what that does is that means that we can eliminate, like, almost entirely the propagation problem and latency. Most of the time it takes to get to finality is literally not the compute of processing the transactions. It's broadcasting it and collecting all those signatures. That takes the lion's share of time. So when you're like, if Raymmar, if you're a authoritative node, and let's say there are 500 appliances around the world, each of those appliances contains enough compute for like the entire network. You have a key in each of those, and you have the ability to authorize or deauthorize each of those appliances, and you have software or an independent path if you don't want to use the software that we build for validation to track the state of each of those machines. And all you have to do is do a transaction on any of the instances of the governance contracts to deauthorize that public key. So now you're able to validate. Now, if you're compelled to, let's say a big, third party wants to compel you to censor transactions from a specific smart contract, like what we see on Ethereum, you don't have an ability to do that. All you can do is deauthorize all your keys, and essentially that's not going to be able. There's not going to be able to. No one's going to be able to apply pressure to manipulate the state. So it's either trustless or it's nothing.
Is essentially where Bitcoin is, right? Like there is no one that can apply pressure to Bitcoin in that production of the blockchain. Like it just keeps going, and we need to get to that layer, plus all of the smart contracts and data and everything that needs to happen on blockchain that Bitcoin can't necessarily do. We need to bring the best of Bitcoin over into this greater world where we can build businesses on top of blockchains.
Yeah, I think that's and that's the key, right? So it's like bringing the core fundamental of the chain is either on, and if it's on, it's trusted, or it's off because it's like off, but once it's on, right? Like, and so now,
what would the reaction have been instead of Tornado Cash being censored? I don't think a lot of people cared about that really, other than like the technical people that understand what that means, if it's possible to happen. But like, what if it was Ethereum got turned off by a government agency or something like that, or they made it illegal to run validator nodes? There'd be a major outrage. Like that would be a huge issue. People would actually be focusing and working on a way to subvert that manipulation. But if it's minor little tweaks and little bits of censorship that grow over time, nobody works. Like every Ethereum developer isn't now focused on the problem, trying to find a solution. So it's ideal to be able to kind of like creep in those levels of control. So that's why our approach is to just make it, on or off. It's got to be trustless. And really, there's not a scenario like in the scenario that you're compelled to deauthorize all your keys. There's not really a way to know if you are, a certain address. So it becomes difficult even for like a third party to try and influence you. It becomes difficult for them to know if you're being compliant or not. So it's not like that simple. but just at a high level, if there's blocks being produced on this compute platform, that they are fully trustless and decentralized.
Yeah, and that I guess what you would want to call censorship creep or fiddling. That, just look at the United States, right? As a country, we started out with the Constitution, we started out with the Bill of Rights. That was a couple hundred years ago. And then since then, you have this secondary layer, which is, Congress, the president, the Supreme Court. And so what do they do all day? They take cases or they add laws on top of that. And a lot of it doesn't even have to be malevolence. Laws happen. They don't exactly work within the confines of the Constitution or the Bill of Rights. Or you just chip away at little aspects of it. Like the Constitution didn't mean this, it actually meant this, or it never knew, like it's a living, breathing document, or we're 200 years ahead of, into the future. We're an industrialized nation now. Like there needs to be new laws. Like that's the kind of thinking that goes into it. And you just start chipping away, and then there's more censorship, there's more laws. It's just a natural progression of how we're humans. We like to fiddle with things. We like to try and make things better. What we need to do on the blockchain side is essentially, here's the Constitution. It's trustless. You can validate, and there is no changing from there. It just is a one-lane road that just continues forward into the future. If you want to build on it, great. If you don't, you don't have to. But this is the path that we're taking.
Yeah, and just to kind of dovetail off that, we have made specific, very important things unchangeable. So, the requirement for what a node needs to be is one of those things. The mechanisms of our governance can't be modified. So, like how keys are authorized, how candidates can end up being elected and sitting on a node. All of that workflow, the tokenomics can't be changed. There can never be a different amount of wire. No more wire can be created after, the initial supply has been distributed. So those things can't be changed. Things that we aren't gridlocked, though, like improvement proposals are going to happen, and they are going to change many different aspects of our chain as we go on. And our chain's designed to scale, to the biggest levels, internet size scalability. So we're not limited in those directions, but we do have a mutability where it's very obvious, at least to us, that we can't imagine a scenario where that would need to change.
Yeah, maybe let's dive a little deeper into the whole concept of the nodes and how the allocated resources work, and maybe you even want to, because we haven't even talked about I think maybe we mentioned it in passing, graphene based, the EOS fork. Like, do we want to talk any depth of the performance factor coming into that? I don't know how deep we want to go. We only got 20-ish. Actually, we got 12-ish minutes here. So, we for sure want to talk about the nodes here, allocated network resources and how that works. But I'm just wondering, is there anything else we want to tie in to make this a fully complete loop here from the tech standpoint?
Raymmar, I think that conversation is probably going to be a really good tie-in for next week when we're talking about real world applications of the hardware in the nodes. I think we can push that off and have a bigger discussion about it.
Okay.
Next, I think what I think we should accomplish here is we have a really good understanding of the hardware now. And then we've talked about the blockchain. I think we get into the how our nodes operate, how our blockchain utilizes allocated network resources, and then when you put that hardware and our blockchain together, what's the beautiful package that it manifests.
Great.
Yeah. So any like computer enthusiasts out there are going to love, you know, the node operator side, because what we're doing is we're making a blueprint, and even down to like you can print the hardware security module yourself, or with a local company that does that. So that just removes like the whole supply chain issue. You don't have to worry about like anti-interdiction services or anything like that. The node operators, the people that will build these machines or buy them and run them in a compliant location, they're going to have a more commercial relationship with the Wire Foundation. So essentially, the closest thing that exists to it would be how Filecoin kind of rolled out their operators in storage deals, which was pretty complicated, even like when I first got into it, just to try and understand how it works. This is simpler. You'll have a trust score based on how long you've been in compliance. And in order to engage and be earning, you have to be up and running, and it'll just go by priority that way. And then as the needs of the network grow, the network will engage these individuals or entities to essentially scale redundancy and then scale the amount of compute, included in the network via network expansion. So you've got a really good platform that's open, not proprietary, all open source code, no proprietary code required, no proprietary hardware required, and we'll continue to broaden, the components like that can be used through continuous development and support on all these various open source projects that we've started contributing to and adopting. So it's not going to be like, Ken and I have a warehouse and a place where we're making computers, not like Helium's a good example of proprietary hardware for their network, being constrained that you can only buy it from their partner, and there's only one company that makes it, and it's got to have a, secret that their organization stamps onto the code for it to be able to like do its thing. We're not going to do that. Our platform, if you build it the way it's supposed to be built, anyone will be able to independently verify that that machine has a trusted boot state and isn't being manipulated over time. And that's being in compliance. So it'll be interesting to see how that scales. And I think a lot of the initial Wire improvement proposals that are going to be discussed in the open forum and improved, those are going to be around node operation and what that means, and defining, how that compliance works, because you got to deal with what like access control, network connectivity, like that has to be special. There's a lot of things to discuss and work out, but I'm very excited and optimistic that this type of compute platform will become more and more mainstream in coming years, with how important, software is going to become and all of that.
Yeah. No, we something that I think is really important when it comes to our, not just the hardware, but having the nodes sit on top of it, is performance. So let's wrap it around to, why we've done all this. So if you look at how Ethereum works or Solana works or any of these traditional blockchains, they had some sort of ICO, or they had some sort of token distribution to get it out into the wild, get it into, thousands or millions of hands. And then with their blockchain architecture, you have developers who build on top of these networks. They build on top of Ethereum. They build things like OpenSea, right? And then you have all the users who have their Ethereum tokens participate. They interact with OpenSea or any other, Ethereum application. And what happens? You are forced as a user to pay the gas fee as you're trying to do transactions on Ethereum or any other, or on OpenSea or any other Ethereum application. It is a very capitalist form of how to, consume and distribute resources. It's just like this open world, like here it is, like everyone deal with it. All other blockchains pretty much work like that. Solana works like that, Polygon, even on L2s. What we've done is we have what we call allocated network resources, which is where all the resources are embedded inside of these blockchain nodes. And you can build an NFT marketplace that is powered by one of these nodes. And when users are interacting with that NFT marketplace, it is drawing resources out of that node and providing it to the user. And so they are experiencing a potentially zero gas transaction fee, where what I like to call a Web 2 workflow, whereas if you go on eBay or if you go on Amazon and you are adding products into your cart, and then you go to your cart and you pay for the items, what happens? You only pay for the items, right? You're not paying some sort of like gas fee for that Amazon's charging.
Just the government gets the VIG. That's it. The only person.
Yeah.
Each add to cart. Each add to cart would be like a MetaMask prompt in a transaction.
So that's, it's kind of like the why are we doing all that we're doing? It's because we need to create a Web 2 style workflow in Web 3. So all the benefits, all the ease of use of how Web 2 operates, eBay, Amazon, Instagram, like your social media, your financial accounts, everything that you interact with every day, you just use it, right? It just flows. You use it real quick. You're in, you're out, and you're gone. We need to bring that into Web 3, blockchain, have all the beauty and all the benefits of blockchain powering it, but in the background, really nice user experience, very powerful, trustless on the back end. And Kyle, I'm kind of teeing it up to you, but this is what our nodes are able to achieve for this next generation of blockchain applications.
Yeah, we wouldn't have the things on the internet if it was, a toll by transaction, and that was a good system, in like 2014. Because you had to be really efficient. You have like such a small amount of bandwidth, and you have demand. You make a system that's going. What other option is there if you can't increase the bandwidth? You basically just need to allow people to spend in order to give self priority to their transaction. With more bandwidth, what we need is a deterministic cost to running an app. Like if you build software and you don't know how much it's going to cost to run it, one day it could be 500% more, and you either have to find a way to pay for that on behalf of your users, or you just push it off to your users, which is what we've seen, because a business can't do that. That's just not it. So the race to the bottom is going to be, as there's more bandwidth available, we have to realign, and the best way is always going to be having a deterministic cost to operate on the long term. And we still maintain that efficiency, like the benefits of, priority by paying, by having smart contracts that aren't powered by nodes, essentially buy, block by block, unused resources from nodes, or the end users buy those resources to transact with contracts that are not set up that way. So we have, the best of both worlds. Now applications that would never be able to work that way, like social media applications or games, can exist on our network, and they can invest into building really cool software and not have to worry about, barriers to entry for mass adoption because people don't have they aren't going to pay for each transaction or whatever it may be.
Yeah. And I like to remove the headlines. So if you look at, you see Web 2 companies, multinational brands, that they're coming into, what we're calling Web 3 or the NFT space. They are coming in, but remove the headline. What are they doing? They're not bringing their core product. You don't have Nike bringing over their Nike.com architecture into Web3. They're not putting their entire sales process on the blockchain. They're doing little NFT, like they did a deal with Artifact Studios for their NFT projects. You have all these companies, Disney, you name it. They're all doing they're taking a little slice and they're dipping their toe in. No one's bringing their entire product in. And so we're looking at it from an enterprise perspective. It's, let's say eBay does want to bring their entire infrastructure from Web 2 on AWS over to blockchain. How do you get there? And with our tech stack, with our hardware and our tech stack, we're going to be, that's where our market fit's going to be. We're going to be able to bring over entire Web 2 core structures into Web 3 and have them operate. And what Kyle was talking about, just before I jumped in, was you can't have variable resources from a major multi-billion-dollar company. Imagine, like Ethereum's gas fee. We've seen it creep up and up and up just the past, let's say 30 to 45 days. At the low, it might have cost you, $1.50 for a transaction when we were hitting the market bottom. But now, like I saw it the other day, where it was going to be $50 for me to push a transaction through to buy like an NFT. Now take that to like an eBay scenario. Imagine you tell eBay, hey, you can come into Web3, but it might be $1.50 per transaction, or it might be 50.
They definitely know before the year even started. They already knew how much they were going to spend on IT infrastructure. Mm-hmm. They know how many people are likely going to come to their properties, web properties. Until that workflow is available in Web3, they're not going to come over. And exactly. I love the premise of eBay being a fully decentralized application. I mean, how awesome would it be, especially in a marketplace where it's person to person? Chargebacks are a huge problem. If I buy a collectible or something that can't be replaced, one of a kind, and I do a chargeback and I just let my eBay account get deaded, there's not really any recourse for the seller. What a perfect, benefit in a Web3 workflow to have immutability and, absolution in a transaction like that.
Mm-hmm. Nice. So let's jump in. I know we had just some final takeaways because we keep coming back to that trustless, concept, and that's kind of at the core of it. That's what drives the hardware. That's what's kind of putting the whole play. It's like that trustless or bust concept here, right? So, final thoughts as we wrap up here of this episode. Obviously, next week we're going to talk more about the crypto gaming and a little bit about that. So we'll talk about that here in a second. But yeah, let's just put our little bow on this conversation here, and let's put all the final takeaways together.
I'll just say, I'd love to hear the community's feedback or ideas around. There's so many new edges to discover when you start to think about building purely on a trustless compute platform. Just like being able to eliminate the propagation problem, that can only happen in a workflow like this. And when other technical brilliant minds are like talking to us, and we're talking about the aspects of our network, they always are like, how are you achieving, the throughput and everything like that? And our solutions are only possible in this workflow. So it's like always a mind blower, because we eliminate propagation to reach consensus, which is great.
Yeah. And yeah, I guess my final thoughts are, when Kyle and I came together, and it was just a perfect fit. And it's like, what are our goals going to be for Wire? What are we trying to accomplish? And let's just not take some small goals. Like, what are the big ones? Like, how do we get to the next internet? How do we get to a trustless internet that scales? And so that's kind of took us down the hardware path. That's what took us down to how blockchain resources are distributed and consumed. Like, this isn't just us just trying to solve a few things for a couple apps. It's how do we bring on Web 2 companies that are multi-billion dollars? How do we bring them into Web 3? And how do we, and you have to do it not only from a user experience level on the front end, but also on the back end for the companies themselves, like an eBay. It has to be a cost benefit. You have to do things better on the back end for them. You have to have increased performance that they just can't have in a centralized, architecture like on AWS or using just database. Like, you have to present to them, you have to incentivize them to come into Web3 on performance, on cost, all benefits. But that's what Wire's doing, and we're going to be, again, if you're talking about market fit for us, I think that we are the only company right now in this space that would be able to bring on Web 2 companies into Web 3 and not lose user experience or performance. So I think that we're just in a great spot with our hardware and the blockchain converging, and what kind of fruit that's going to bear for us.
Yeah. I see Waver here is asking a question about how the deeper context about how the nodes work. We're not going to get deep into some of that, but if you're interested in learning more, if you want to go to wire.network, you can definitely get in touch with us there. We're happy to go deep into a call if you're interested in either building technology on this, or if you're interested in investing at any level. We're talking to people all over the world about this stack and what we're doing with it. Last week we had the Satoshi Roundtable wrap up with Ken. He was in Dubai. We're going out to LA for what is it? The NFT LA. They got a new name for it now, though. What's it
Outer
called?
Edge.
Outer Edge is what they're calling it this year in LA. We've been making the tour and talking to just lots of different people in this space. And every time we get into the technical conversation, when we get deep into the weeds, and they start understanding the nuances of how it all works, there's always this like, oh, okay, I hadn't really thought of it that way. Or Kyle, how many times have we been sitting down after an hour or two with some technical person, and they have this like aha moment where it finally like makes sense for them, and they're like, oh shit, I never even thought about that. Literally that phrase I've heard a number of times, from people that I won't mention, but very respected in the crypto space, who literally, oh, I never even...
Yeah, don't put anybody on blast.
That's what I'm saying, right? But like literally that line, like, oh, I never even thought about that.
That's what's good though. Like it's because you're creating new edge. So it's always a safer route to not, put a big focus on R&D and to just try to build, a small product or a slight, improvement. That's a safe route. That's not the route we've taken, obviously. So we've created a lot of new edge, and that's why when people are, getting into the deep depths of our tech stack and what's possible, that's their reaction, because there's just insane amounts of new possibilities for your software to run on a blockchain in Web3 that those possibilities just don't exist right now in other protocols.
Yeah, we're aiming high. There's no doubt about it. But the other side of that is we're executing. Like, no one can say that we're not accomplishing our goals. We're knocking them down left and right. So we're allowed to aim high. You know, if you have people give Elon Musk, a hard time because he has the Boring Company, he has SpaceX, he has Tesla, he has Neuralink. He's executing, as long as he has Twitter now. He's executing on all of those. So if you're executing, you can't hold that against us. It's actually, a benefit. Like, it's awesome that we're able to do that. And we're in that same boat. We're accomplishing everything that we're setting out to do. So, all we need is more support. Just help us out.
Yeah.
I think it'll become like pretty apparent as we near our rollout of wire name service on Ethereum style networks, just how good this is going to get. That's been a huge effort, and I was working late with some of the core engineers last night, just finalizing and test flighting all that we've been doing there.
Yeah.
So true native interoperability.
Right. Yeah, it's one of those things. We talked about it in the past few episodes. This stuff takes time to roll out. Even somebody the other day in the Discord, I was looking back and they're like, "Oh, that YouTube thing's not really working out for you, huh?" And I'm like, "What do you mean?" Like, there's plenty of people watching. Okay, is it viral? Is it millions? Is it thousands of people watching every stream? No. Does that matter right now? No. Right? These are slow baby steps forward. The technology rolls out, you make a little innovation. Somebody sees it, you catch their interest. They're like, okay, how do we plug it in? Boom, they build a little something. They build a little something. Next thing you know, you've got this foundation, and slowly things starts poking up. Think about how you build a building, right? Like a construction site, you could go to a building and not see anything for a year, right? While they're putting the pilings in and digging the foundation and doing whatever. And there's a lot of time where you're like, it's just whatever. And then one day you drive up and it's like half built and you're like, holy fuck, right? Because once you break ground and once you kind of start putting the frame up, then the things start coming together. Like, holy shit, look how beautiful that building is, right? I wish I'd have bought some real estate close to that thing. And so then the windows start going in, and then all of the fittings and the fit and finish and all that. And then by the time it's up and people are ready to come inside and check it out, like, it's too late to make an investment. It's too late to buy the penthouse at the top or to get a space inside the thing. Like, it's done, right? And so that's what happens a lot of times with all these technologies. So if you're watching, thank you. We appreciate you. You're on the cutting edge of something that's very new. It's very ambitious. This is a big project, right? That's why it takes a lot of time to try to explain and lay these things out. And so it's going to take a little while, but trust me, the things are popping off. Like Ken said in the back, there's a little thing, there's a dot that connects over here. There's a little thing that goes over there. We find the right partner over here, and those things are happening. And we're super excited just to kind of keep sharing this story with you all. So we're going to keep building in public. We're going to keep sharing all of this stuff as we go. And, in a year or two, as this thing explodes, we'll be able to look back at how like silly some of these live streams were, or like we'll laugh at, how awkward some of the moments were where we just didn't really know what we were doing, but we were just trying to figure it all out. And I think that's the fun of this. That's that startup culture. And one thing will always be as authentic and honest. And so with that said, I think we'll wind down. Next week, we've got the future of gaming. So we've got a couple special guests from our ecosystem coming to hang out with us. Let's go into this view here. We'll have the folks from the Dragon Spawn team, as well as we're talking to one other potential person to join us. So stay tuned for that. We're here every Thursday at 12 p.m. Eastern, although we're experimenting with different times. So we'll let you know if that changes. But any closing thoughts, Kyle, Ken, as we move into the next space here?
I will say that we are definitely close to doing there's going to be a lot of releases this year and soon. So it's not going to be like a Cardano situation or anything like that.
Hope Charles isn't watching this. Sorry, Charles. Yeah, I agree. We'll wrap up there. We have so much that will be rolled out this year, a lot of it very shortly. And next week, it's not going to just be Dragon Spawn and gaming. Kyle and I are going to get into what are the real world applications for the infrastructure that we built, what's currently in the pipeline. And it'll be a great conversation.
Great. All right. Well, that's what we got. We appreciate y'all hanging with us. It has been a, fun time. It's always exciting. I've done this a couple times with folks where it takes a little time to build up the momentum around these streams, but it's always fun to build the chemistry, to meet the audience a little bit. So as you guys go, just remember that we're just hanging with y'all. Nick, thanks for hanging with us on the stream here. Steve, hello, thank you. Daniel, Mandoc's in the house. What's up? Waver, thank you so much. Everyone who John Day was hanging with us, Pragma Solidity. So everyone, we appreciate you hanging with us. We're gonna get a lot more friendly as we go. Oh, we've got a meetup. If you're in the Tampa area, if you're in Bradenton, Sarasota, Tampa, St. Pete, anywhere, we've got a meetup coming up March 15th. So let me see if I think I have that up here. Let me escape this. Yeah. South of the Bay blockchain. We just started this up. We've got an event coming up. If you're in the area, you should totally join us for this. Decentralized Connections at Motorworks Brewing. We've got 10 folks already signed up to come and meet us out there. This is what the live stream's about. This is what my goal is to really start humanizing this product, start bringing it to the ground level, start finding interesting ways to get out into the world and let people know that we're actual people trying to solve real problems that we all deal with on a daily basis inside of a digital space and with a technology that that we're trying to understand all in real time. And so anyway, come hang out with us. This is gonna be a lot of fun. I think that's it. Any final thoughts, guys?
Yeah, I'll try to respond to some of the questions in chat too. Nice. After the stream.
Boom. Got him. All right. We're going to bring this thing up. That's our little jam. Bring it to this thing. And yeah, it's been real. Talk to you guys soon. Bye, everyone.
Thanks, everyone.
See you guys next time. Bye-bye.